So this is the continuation of our discussion on properties of signals and noise, wherein we are on the part where we are comparing yung ating physical signal, or yeah, physical signal, and yung mathematical model ng signal natin. Okay? So we are on the argument na our mathematical model, or the mathematical model of our signal approximates that of or approximates the physical signals that we have. Okay? So although actually we have also included in the comparison, okay? We also included in the comparison, okay? Yung aside from the two, okay? Yung aside from the mathematical model, okay? Aside from the mathematical model, math model of the signal, okay? Versus the physical signal itself. Okay. Aside from these two, we are also comparing yung tinatawag nating computer-generated signals. Okay. So, what we have known so far is yung ating mathematical model, okay, possesses all the ideal properties of your signal, okay, which cannot be or which would approximately describe yung physical signal natin. And these two, okay, can actually be represented by by generating values in a computer, okay, that resembles yung properties ng mathematical model tsaka ng physical signal natin. But then again, there are properties that the computer generated signal, computer generated signal that that is not, or that cannot be, or that or there are properties ang ating physical signal that cannot be possessed by our computer generated signal. Okay? And in the same manner, okay, hindi natin mapipilit, for example, si computer generated signal to possess a property of your physical signal. So isa na nga dito is yung pagiging discrete time in nature ng ating computer-generated signal. If your physical signal is continuous in time, okay, if you try to model this physical signal using a computer-generated model, okay, you cannot generate the full continuous time signal, okay, using a computer kasi nga your computers are of finite memory. Okay? They are of finite memory. Okay? And therefore, they can only generate finite amount of values. Okay? So, what we can do, or what we can do to approximate yung pagiging continuous time nito is that we increase yung tinatawag nating sample or sampling rate. Okay? Or i-clear natin yung sampling interval. Okay? We increase the sampling rate or we decrease the sampling interval. It means the sampling interval means the time between samples. So if you can make this time between samples very very small, okay, we can approximate now your continuous your computer generated signal as a continuous time physical signal. Okay? So ayun. Isa pa yung we say that the physical signal, okay, the physical waveform or the physical signal would be an energy signal, okay, because in reality, you cannot generate a waveform, or you cannot make a circuit, okay, or you cannot build a circuit that would generate a waveform of indefinite length, or of indefinite interval. Okay? So, yung physical waveform natin tends to be an energy signal. Whereas yung mathematical model natin tends to be more of a power signal. Which means that if our mathematical model, right, if our mathematical model calls for a signal that persists, okay, or that is persists over time, over time from negative infinity up to positive infinity. Okay? Hindi natin magagawa yan physically. Okay? Basically because the circuit, okay, the circuit or whatever, or the computer, okay, the device that would generate that waveform, okay, would not be able to generate would not be able to generate signal that's this long. Okay? So physically we say that your signals, okay, are energy signals. Okay? But we will use power signal mathematical models so that we will have so that our analysis will be simpler. Okay? So we use the term waveform. Okay? We use the term waveform to pertain to signals, okay, signals of any measurable quantity. Which means we'll use the term waveform pag hindi natin alam kung ano yung mini-measure, hindi natin eksaktong or hindi tayo particular with the quantity that the signal is measuring. Okay? Pero kung alam natin siya at kung particular tayo at kailangan talaga yun ang i-measure natin. Say for example, we say voltage waveform, okay, or current waveform, okay, then we will use those terms. Pero kapag hindi naman tayo masyadong particular, okay, then we will use simply waveform. Okay? So now, waveforms or your signals can be classified as information. Signals here mean information-bearing signal. So information-bearing signal. Okay? So your waveform can be classified either as an information-bearing signal, or it can also be classified as a noise. Waveforms can be digital or analog. Okay? It can be deterministic or non-deterministic. So which means pag sinabi niyo deterministic, ito yung may mathematical model. Okay? May mathematical model that is predictive, or that allows us to predict so allows us to predict, that is predictive. Okay? Pag non-deterministic naman, if your signal is non-deterministic, it means the signal is described statistically. Meaning, we don't really know, or we cannot really predict the values of the signal or of the waveform. Okay? But we can yung appearance of the values can be described statistically. Okay? Or meron siyang statistical properties which we can quantify. Okay? So waveforms can also be physically realizable or non-physically realizable. Okay, so we know na nabanggitan natin yung ilan sa mga characteristics ng physically realizable waveforms. Okay, such as yun nga, dapat finite time siya. Okay. Whereas non-physically realizable waveforms are those that are that are of infinite or of infinite length. Okay? So ayun. And waveforms can either be power or energy type. Okay? Now, we will also include in the classification or in the characterization of your wave yung pagiging periodic niya. Okay? So, which is really important in understanding the behavior of your signal. Okay? So, yun. Now, um, one of the most important operations that we always do, okay, when dealing with waveforms is the time average operator. Okay? So, when you say time average operator, this averages, okay? This takes the average of your average value of your signal over time. Okay? So, some of the useful waveform characteristics of your some waveform characteristics that are useful in describing your waveform are the DC value, okay, the average power, and the root mean square, okay, or the RMS value. Now, all of these characteristics can actually be computed, okay, using time averaging. Okay, so the time average operator is given by the limit of this integral. Okay, yeah. The time average operator is the limit of this integral. So, as t approaches infinity. Okay. So, here, um, we see na ang ating, here, ito yung mga ibig sabihin ng mga nakalagay dito. This one represents your signal or your waveform. Okay. The the function in which we will do the operation. At TA, okay, is the operation. Okay, is the operator. So which means if we have, say, for example, TA, then we enclose something like f of t inside that one. It means that we are applying the time average operation on the function f of t. So which means ipapalit natin tong f of t na to dun sa integral niya. Okay? So, there, yun yung ibig sabihin ng notation na to. Okay? So, it is seen that this operator is a linear operator. Okay? Since from equation 1, the average of the sum of two quantities is the same as the sum of their averages. So, that is, if we actually have two waveforms, okay? Waveform 1, waveform 2, and both are weighted, or both are scaled by A1 and A2 respectively. Okay. Then we will be able to reduce this waveform, okay, into two components. Okay, ito component to, tsaka itong component na to. So if since this operation, okay, since this operation is linear, okay, this would be the result kapag ka naghahanap tayo ng time average ng dalawang waveforms ninyo. Okay, so we simply add their time averages. Okay, so ayun. Anyway, the linearity of the time average operator is an implication from the integral operation. So there. Now, equation 1 can be reduced. Okay. Equation 1 can be reduced to simpler form if the operator is operating on a periodic waveform. So kung yung natin dito, yung function natin dito is a periodic waveform. Okay. Then we can reduce equation 1. Okay. We can further reduce equation 1. Okay. So how do we say that a waveform is periodic? Okay. So a waveform is periodic a waveform WT is periodic with period T0, okay, if WT or W of T equals W of T plus T0, okay, for all T and T0. For all T, and T0 is the smallest positive number that satisfies this relationship. Okay, so ang ibig sabihin nito, itong ano to, equation na to, or itong condition na to is that kung merong value say for example, ito yung ating ito yung ating waveform. So for example, this is the waveform that we have. Ayan, no? Okay. So, say for example, we get a time here, say T1. Okay, so the value of your waveform at T1 is W T1. Okay, it's the value of your waveform at time T1. So that's W T1 here. Okay. Now, if there is a number T0, okay, if there is number T0 such that inad natin siya dun sa T1 natin. So, halimbawa ito sa T1, tapos inad natin si T0. Halimbawa ito yun. Dito siya lalabas. So, this T. Meron dito lalabas si T1 plus T0. Okay? Now, this would be the value of your waveform at that point. Now, if we find out that the value here, which is now W of T1 plus T0, at nalaman natin na itong dalawang yan ay equal. Okay? Tapos, kahit saan T mo siya i-apply, okay? Whether T here, okay? O kaya T here, okay, and so on. Kahit saan T mo siya i-apply. Okay? This equality is true for all T. Okay? You would see that yung waveform niyo is actually a repeating waveform. Ibig sabihin, meron siyang isang parte niya na inuulit niya. So, meron siyang isang cycle. Okay? Meron siyang isang part ng waveform niya, which is what we will call the cycle. Okay? Which tends to repeat. Okay? So, tends to repeat every so often. Okay? Ngayon, kung gaano siya katagal, how long is that cycle is yung T0. So, say for example, in this case, no, ito yung repeating cycle, or ito yung cycle na umuulit dun sa waveform niyo. So, meaning na kahit saan nyo tingnan yung waveform nyo, makikita nyo yung pattern na yan. Okay, so syempre hindi ko siya ma-drawing lahat dito. Okay, pero if we can represent this waveform in a manner na mauulit-ulit natin lahat yan. Okay, yung pattern na to. Okay, kung gaano katagal yan, okay, kung gaano katagal yung cycle na yan is our T0, or what we call periodicity. Okay, so if there is such a number T0 for our signal, okay, then we will be able to say that your signal is, or that your waveform is periodic. Okay, so an example of so one example of a periodic waveform, okay, one example of a periodic waveform is a sinusoidal waveform. Okay, so periodic yan sigurado. Okay, now the frequency of a single sinusoid waveform is f0, which will be equal to the reciprocal of its periodicity. Okay, so we can actually see it here. Okay? Pwede siya makita dito sa example natin dito. Okay. So in here, I've drawn, okay, or I plotted a sinusoidal waveform with frequency of 2 Hz. Okay. Ang equation ng waveform na to is actually 2 sine 2 sine 2 pi times 2 times t. Okay? So, ngayon, napapansin natin na yung waveform ninyo, the value of the waveform at negative 0.96, okay, or at t equals negative 0.96. Okay? Yung value ng waveform ninyo at t equals negative 0.46, yung waveform ninyo, value ng waveform ninyo at t equals 0.04 and at t equals 0.54. Okay? Lahat yan napapansin natin na equal yan sa iisang value. Okay? Which is 0.9635507. Okay? So, kung papansin nyo ngayon itong mga values, okay? Those values, ito, tsaka to. Pag yan sinubtract nyo, pare-pareho yung difference nyo. Say for example, pag sinubtract nyo yung 0.54 minus 0.04, lalabas dyan is 0.5. Okay? Pag sinubtract nyo yung 0.04 with negative 0.46, lalabas dyan 0.5. Okay? In the same manner, pag sinubtract nyo yung negative 0.46 minus negative 0.96, lalabas dyan 0.5. So, ano yung point ko? Okay. Ang point ko is ganito. If we are to start with writing the value for t equals negative 0.96. Okay. Itong W of t equals negative 0.46 can be similarly written as W of t plus 0.5. Okay? Kung ang t natin is negative 0.46, pag dinagdagan mo yun ng 0.5, pag ang t mo pala is negative 0.96, okay? At dinagdagan mo siya ng mali pala to. So this is W of negative 0.46. No. Now, if we start at W of negative 0.96, okay, pag itong negative 0.96, dinagdagan mo ng 0.5, magiging negative 0.46 siya. And it happens na yung value nito equal sa value nito. Okay, which is both 0.963 507. Okay? In the same manner, yung ating W ng negative, gawin natin to, gawin natin itong instead ng negative 0.96 plus 0.5. Yan. In the same manner, yung W of negative 0.04 ninyo is actually equal to W of negative 0.46 plus 0.5. Okay? Which, yun nga, nakita natin as 0.963507. And, di pa siya negative, positive pa siya. Okay? And then finally, yung ating W of 0.54, okay, is equal to W of 0.04 plus 0.5. Okay, so which is yun nga 0.963507. Now we can go on, okay, and see na kahit anong t Okay? Kahit anong t ang piliin natin dyan, we will still have the same, we will still arrive at a true statement. Okay? So, kung tuloy natin to, this is still equal to negative 0.96. Ito naman, equal pa rin sa negative negative 0.46. Ito equal pa rin sa 0.04. And so on. So, ito yung natin, yung WT natin. Tapos ito yung dinadagdagan natin ng T plus T0. So, nalaman natin na yung value nito at yung value nito. Okay, yung value ng waveforms nyo at those times. At negative 0.96 saka negative 0.46, pareho lang. Okay, which yun nga. Ito. Yan. Pwede rin kayo pumili ng iba pang time. Say, for example, ito. Okay. So, yung value ng waveform ninyo at negative 0.54, yung value ng waveform ninyo at negative 0.04, tsaka yung value ng waveform ninyo at 0.46, lahat yan equal sa negative 0.963, 507. Okay? So again, yung value nung waveform niyo at negative 0.04 can be obtained, okay, by from the expression W of negative 0.54 plus 0.5, okay, which lalabas nga dyan is yung ito nga, yung W of negative 0.04 ninyo. Okay. But still, yung mga values na yan, equal pa rin sa negative 0, sa value at T equals negative 0.54. Okay. So in the same manner, yung W of 0.46 natin is equal to negative 0.04 plus 0.5, okay, which is still equal sa the value of the waveform at t equals 0.04. Okay. So, ito yung WT natin. Pag si t, argument t dito, dinagdagan natin ng T0, okay, equal pa rin sila. Okay. So, if we can prove that, okay, if we can prove that for all t, if this is true, okay, if this is true for all t, okay, then yung waveform natin is periodic. Now, pansinin natin na in all of these cases, consistent yung T0 ko, which is 0.5. Okay. So, yung T0 ko dito is 0.5. This is actually 0.5 second. Okay. Yung 0.5 second na yan, ito yan. Gaano katagal ito? Or gaano katagal, itong interval na to. How long is this interval? Yeah. So, that is your T0. You can also measure T0 here. So, from here to here, kung gaano katagal yan, that is T0. Okay. Now, take note that T0 is 0.5 second. Okay. Pag kinuha natin yung reciprocal niyan, that should give us the frequency of our waveform. Okay. So, makukuha natin dito is 1 over 0.05. 1 over 0.5 second. So this will give us 2 cycles per second. Or ito yung minimeasure natin as 2 hertz. Okay? So, now, since single sinusoid lang yung ating pinag-uusapan, yung ating waveform is a single sinusoidal waveform or isang sinusoid lang meron siya. Okay? So, yung F na yon happens to be the frequency of that sinusoid. Ito. Remember na ang general form ng isang sinusoid is A sine or cosine pala. It's usually cosine. We use cosine for A cosine 2 pi times F times T. Where F here is the frequency of the sinusoid. Okay. O kaya, minsan, sinusulat natin ito as A cosine of 2 pi times T over T. Okay. T here now is the periodicity of your waveform. Okay. So, yung 2 na to, nakuha natin yan as the periodicity of the periodicity here. Okay. Which is consistent dun sa definition ng number 2. Okay? So lahat ng waveforms that that comply with this requirement, okay? Not just sinusoids, okay? But kahit anong waveforms that satisfy that are said to be periodic. And kapag periodic yung sinusoid niyo, okay, pag periodic sinusoid niyo, ganyan siya. Meron siyang pattern na nauulit. Okay, by the way, saan pala natin mababasa yung tinatawag na F equals 2 cycles per second? O kaya 2 hertz. Ito siya. Yung 2 cycles per second na yan, mag-measure tayo ng from 0 to 1 second. So ito, hanggang 1 second ito. So yan, 1 second dyan. Okay? So 1 second dyan. Bilangin natin kung ilan yung mauulit na cycles ng ating waveform. Okay? So, bibilangin natin kung ilang cycles yung mauulit sa kanya. So, starting from here, okay? So, you have 1 cycle. Okay? So, 1 cycle. Sorry. Ito pala. Yan. So, yan yung isang cycle niya. Okay? And then, the next cycle is from here to here. Hanggang sa makumpleto natin yung isang buong segundo. Okay? So, kung ilan yung cycles na mabibilang natin sa loob ng ilang cycles ang naulit sa signals ninyo o sa waveform ninyo within 1 second. Okay? Within 1 second of time. Okay? Then, that's your frequency. Okay? So, in this case, there are 2 cycles. So, 1 cycle. And then, another cycle. So, there are 2 cycles na naulit sa kanya. So, therefore, ang frequency natin is ito. 2 cycles per second. Okay? So, that's how we interpret yung waveform natin. Okay? So, again, from the definition of the periodicity, okay, and of periodic waveforms, you would see na ang periodic waveform will persist from negative infinity up to positive, from negative time up to positive time. Okay, so magpe-persist ang periodic waveform ninyo from negative infinity up to positive infinity of time. Okay, so therefore, ang length or ang duration ng isang periodic waveform is infinite. Okay, so therefore, again, going back to the discussion natin earlier in which you cannot really generate, okay, you cannot really generate a physical signal, okay, that is or that has infinite duration Okay? So we conclude or this implies now that physical waveforms cannot be truly periodic. Okay? So technically, ang mga physical waveforms niyo are not or cannot be periodic. Okay? Pero ang ano natin, ang sagot natin diyan is this. We will consider them to be periodic. Okay? We can consider them to be periodic. Okay? But periodic only, okay, over a finite interval. So ibig sabihin, hindi siya periodic all for all t. Okay? But periodic siya for a certain interval of time. Okay? So say for example, sabihin natin periodic yung signal ninyo or yung waveform ninyo from t 0, t equals 0 up to t equals say 1,000 seconds. Okay? So yung physical waveform natin will have a duration of 1,000 seconds. Okay? But mathematically, that waveform is not really a periodic signal. Okay? Maaring periodic siya sa maaring periodic siya sa interval na to, but not for the entire range. Okay? So, ayan. Now, as we stated previously, equation 1 can be reduced to a simpler form if the operator, or if the operand is a periodic waveform. Okay? So, mare-reduce natin si time average operator if the operand, okay, is periodic. So, how would we reduce that? Okay? So, first thing, yung limits ng integral natin, okay, would be set dun sa limits dun sa time interval for which the signal is periodic. Ibig sabihin, kukunin natin yung time interval, okay, for which makaka-capture natin yung isang cycle yung signal natin. So here, bawa dito, ang kukunin nating limits ng integral ninyo would be yung lowest time kung saan magsisimula ang cycle at kung saan siya matatapos. Okay? So in this case, nalaman nga natin na isang cycle ay tatagal ng 0.5 seconds. Okay? Nalaman na natin yan. Okay? That one cycle would last for half a second. So kung magsisimula si cycle ninyo at t equals 0, matatapos siya na t equals 0.5 second. Okay? So ngayon, ito yung gagamitin natin limits ng integral ninyo dun sa TA natin. So isa-set natin ito ngayon. Halimbawa lang ngayon yung kino-consider natin. Yung yung limits natin is magiging 0 hanggang 0.5 second. Okay? And of course, T0 here is the periodicity. Okay? So, ayun. Again, mawawala na yung operation ng limits. Okay? Because since we will be averaging now. Okay? We will be now averaging your waveform, okay, for one cycle only. So, i-average natin siya on one cycle. Okay? Ang assumption kasi nito is that, yung signal niyo kasi is a power signal, no? Okay? So, once na maging power signal siya, okay, what we simply need to do sa operation ng time averaging is to simply capture the average of one cycle. Okay? So, once ma-capture natin yung average ng one cycle, untitled, okay tayo. Okay? Whereas kasi dito, this does not take into account whether your signal is power or energy. And in fact, dito, ang assumption niya actually dito is that your signal is an energy signal. Okay? So, but whether it's an energy signal or a power signal, ang ginagawa natin kasi natin dito is that we would try to average your entire signal. Okay, we would average the values of your signal for t from negative infinity up to positive infinity. I-average natin siya dyan sa duration na yan. That's why meron tayong limit dito. Okay? So, ayan. Dito kasi, since umuulit-ulit naman yung pattern ng signal ninyo, then kunin natin yung isang pattern. Okay, tsaka natin siya i-average. Okay? So, and since average naman siya, okay, since this is an average naman, that average would be consistent. Or the value of the average would be consistent. Kahit saan mo siya kuning cycle. Whether you obtain it here sa cycle na to, or kunin mo siya sa cycle na to, or pwede mo rin siyang kunin sa cycle na to, or dito, you would obtain the same values. Okay? So, yun yung average. Okay? So, there. So, yun na nga, ito yung explanation kung bakit the integral reduces, the time average operator reduces from equation 1 into equation 3 once the operand is periodic. Okay? So, since periodic nga siya, meron tayong mga identical areas. Okay? So, as these integrals are summed, okay, if we add up all those integrals, okay, the total area and t are proportionally larger. So, pag inad mo yung mga magkakapareho naman, okay, pag inad mo yung mga magkakapareho naman yung values, okay, at in-average mo siya, babalik ka rin dun sa parang in-average mo yung isa lang sa kanila. Okay. So, ayun. Resulting in the value for the time average that is the same as just integrating over one period. Okay. So, in summary, equation 1 may be used to evaluate the time average of any type of waveform. Okay. So, whether or not it is periodic, equation 3 is for periodic waveforms only. Okay. Now, let's learn how to evaluate now your DC value. Okay. So, the DC value of your waveform is given by the time average of your waveform. So, simply, the DC value, okay, is the limit of 1 over t times the integral of w dt from negative t over 2 up to t of 2. Okay. So, for any physical waveform, we are actually interested in evaluating the DC value only for over a finite interval of interest. Okay. So, if we are talking about physical waveform which will be defined between say T1 up to T2, okay, then the DC value is simply this one. Okay. So, pili lang tayo nung parang interval na kung saan naka-define si waveform natin. Okay. So, however, if you use a mathematical model, okay, of infinite duration, kung infinite yung duration ng ating ano natin, okay, babalik tayo dito. If the mathematical model has an infinite duration, okay, we will need to still use this definition for your DC value. Okay, so that's DC. Okay, next, power. So in communication systems, if the received average signal power is sufficiently large compared to the average noise power, information may be recovered. So ano yan? That's the general rule of the thumb of a communication system. Okay. So your signal, okay, meron tayong tinatawag na pag dumating na yung signal sa receiver niyo, sa receiving end niyo, okay, meron tayong tinatawag na noise floor. Okay. So meron tayong tinatawag na noise floor. So that noise floor is the level of the noise that is present on the receiver side. Okay. Now, ang recovery of the information or the success of receiving the information from the transmitter is determined by whether or not your signal, okay, your signal level is above this noise floor, okay, or not. Okay? So, kapag ang signal ninyo, okay, if this signal is above, this is received signal level. So, if your received signal level is above the noise floor, the level, again, the noise floor is the level of noise. Level, I mean, this means power, no? Okay. The level of noise present at receiver side. Okay. So, more or less, medyo merong certain value yan. Okay. Now, if your receive signal level is above that noise floor, okay, your information may be recovered. Okay. So, yan yung general rule of thumb natin. Kapag yung na-receive nating information sa receiver side is above the noise floor, okay, we will be able to recover the information, okay, from the signal. Whereas kung it is below the noise floor, this now represents lost information, okay, which will turn out as error. Okay, later when your signal is demodulated and decoded. Okay. Mawawala na siya kasi mas mataas pa yung noise sa kanya. Okay, mas mataas pa yung noise power kaysa doon sa signal power. So therefore, the information that is embedded on those segment of your waveform that is below the noise, whose level is below the noise level at the receiver side, okay, it would now be lost. Okay, so yun yung general rule of the thumb natin. Okay, so ito yun. So if the received average signal power is sufficiently large, okay, compared to the average noise power, information may be recovered. So therefore, average power is an important concept that needs to be clearly understood. Okay, so we have defined power as work per unit time, but this is that work per unit time is that is mechanical power. Okay, we're talking about here electrical power. Okay, so electrical power is expressed in terms of voltage. Okay, so that is work per unit charge. Okay, and current as charge per unit time. Okay, so this is the basis for the definition of power in terms of electrical quantities. Okay, now let V denote the voltage across a set of circuit terminal, and let I denote the current into the terminal. Okay, so both V and I are functions of time, meaning they change over time. So ito yung V or yung voltage across your circuit, and this is the I or the current flowing into the circuit. Okay, so the instantaneous, okay, when you say instantaneous, when you say instantaneous power, it's the power delivered by the circuit, okay, at a particular instant of time. So that's instantaneous power. Or in other words, instantaneous power also means incremental work divided by incremental time. Okay, so basically in mathematical terms, that's the instantaneous power is essentially your delta work divided by delta time, okay, as the limit of delta work over delta time, okay, as both of them, or as delta time approaches 0. Okay, so that's the instantaneous power. Okay, so we can also define that instantaneous power in terms of the voltage waveform and the current waveform as their product. Okay, anyway, ang kailangan lang natin gawin dito is magbigay lang tayo ng T. Okay, say for example, T as T1, then we have the instantaneous power at T1. So yung P of T1 is the instantaneous power at T equals T1. Okay? So, by definition, the instantaneous power flows into, okay, the circuit. Ibig sabihin, papasok siya. Okay? When PT is positive, that means that means your current is, your circuit draws the current. Papasok yung current sa circuit mo pag positive yung power. Okay? And the circuit throws out, okay, or gives off power, okay, when P is negative. Okay? So, if this circuit is is essentially a, say for example, receiver, kung receiver itong circuit natin, gusto natin positive yung power natin. Okay, yung instantaneous power natin. Because we would like the signal to go in the circuit. Okay? So, ayun. So, let's have this one. So, let's plot the instantaneous power, okay, as a function of time for a circuit that has a sinusoidal current, okay, with a peak value of 5 amperes and a sinusoidal voltage with a peak value of 10 volts. Okay? So, so since this is a plotting exercise, let's use MATLAB. Okay? So, to generate the voltage, current, and the instantaneous power waveforms. Okay? So, let us first define the parameters of your waveforms. Okay? So, since since this is or we will assume na itong circuit na to, okay, is connected to the main outlet, okay, or to the mains. Okay? We will assume, or we will have its frequency, okay, to be 60 Hz. So ito yung standard na frequency of the main outlet that we have at home. Okay, so yun yung pinaka-standard na frequency. Okay, so yun, the standard power line frequency. We call it the standard power line frequency. Okay, so we define it in MATLAB with this statement. Okay, and let us also compute for what we call the angular frequency. Okay, so this frequency here, yung f of 0 equals 60 Hz. Okay, gives the number of cycles per second. Okay, but we have also what we call yung angular frequency, omega O. Okay, which is defined as 2 pi FO. Okay, and 2 pi FO gives the radians, okay, per second. It specifies, okay, yung omega O, okay, specifies the frequency in terms of angle instead of in terms of number of cycles. Okay. Minsan magandang shortcut kasi yung yung nag-omega O tayo. Okay. Pero if you're really concerned with the frequency of your waveform, madalas mas gusto nating naka-expose si F0. Okay. So nevertheless, we define them both. So F0 is 60. Then we have also W0 equals 2 pi F0. Okay. Then let's choose, or let's define the time interval for the mathematical model. of our waveforms. Okay? To be from 0 up to 0.03 seconds. So, ano lang ito? Arbitrary choice lang ito. Okay? Even this 0.002 here. But still, remember na itong 0.0002 here determines the spacing or the time interval between samples of the waveform. Okay? So, ito yung sinasabi natin na since computer generated yung ating signal or yung ating waveform, okay? We would like this time interval to be as small as possible if we are trying to model a continuous time waveform. Okay? If you're trying to model a continuous time waveform, we would like this interval to be small. So small between samples. Okay? Bakit kailangan small? This is because we would like we would like this we would like that that interval to be very small so that yung magiging resulting data set natin, okay, would have very small spacing between samples na magmumukha na siya talagang continuous time. Okay? So, yun yung sinasabi natin with waveforms that are generated using computers. Okay, we would like this interval to be as small as possible. Okay? Kaya lang, wag naman masyadong maliit kasi baka dumami naman masyado yung data points niyo. This also dictates how many data points you would have. Okay? So, mas maliit yan. Ibig sabihin nun, for a fixed time interval, okay, mas maliit yung interval between samples, that would imply more samples between t equals 0 and t equals 0.03. So, pagka masyado maraming data points natin, okay, baka mahirapan naman sa computation yung ating MATLAB. Okay? So, here. Now, so we have defined the frequency parameters of your waveform. Now, let's proceed now by generating the voltage and the current waveforms. Okay, using the cosine function. You can also use sine function here. Okay, but here we will be using cosine function. Okay, assuming this form. Okay, so again, yung nakikita niyo ditong form na to, tsaka ito, these are the general form of your sinusoidal functions or sinusoidal waveforms. Okay, so that's A cosine 2 pi FOT plus theta, o kaya A times cosine omega OT plus theta. A is the peak value or the amplitude, okay, of the sinusoid. F0, as already stated earlier, the frequency, the absolute frequency. Omega 0 or omega O, the angular frequency. Okay. This is in radians per second, no? Okay. And theta is the amount of phase shift. Okay. Either in radians or in degrees. Okay. Normally, we can specify the phase shift in radians. Kaya lang, minsan kasi mas intuitive sa atin kasi yung degrees. So in this case, in most cases that we will consider here, we will consider this phase shift to be in degrees instead of in radians. Okay. So Yun. Now, so, yun na yung mga complete parameters, okay, ng ating waveforms. The amplitude, okay, the frequency, either the frequency or the angular frequency, and the phase shift, okay. So, the amplitude or the peak values of the voltage and current waveforms, okay, are specified in the problem. So, the peak value of the voltage daw is 10 volts, okay, while the peak value of the current is 5 ampere. Okay. Now, the problem did not mention anything about the phase shift. Okay, so we will set the phase shift, okay, to 0 for both voltage and current waveforms. Okay, so we now define those parameters here. So we define the phase shift parameter. Okay, we define now. Now, this is where we define the current waveform. So the current waveform is 5 times cosine times omega O. Again, omega O was defined earlier as this one. 2 pi times f times t. Okay. Plus theta times pi divided by 180. Okay. So again, if we are to define theta to be in degrees. Okay, if we are to define theta to be in degrees. Okay. Once na ilagay natin siya dun sa loob, okay, or once that we introduce that phase shift inside the cosine function, it needs to be in radian. Okay, because yung omega O t plus theta, kailangan niya naka-radian kasi. Okay, naka-radians kasi yan. Just remember that all trigonometric functions of MATLAB, okay, require radians. Require angles in radians. Okay, it require angles in radians. So that includes yung sine, okay, cosine, saka tangent. Okay? So, for example, kung meron kang sine of A, cosine of A, at saka tangent of A, A here should be an angle in radians. Okay? So, therefore, kung halimbawa meron tayong cosine of omega OT plus theta, dapat si omega OT plus theta must be in radians. Okay? So that is why, ang ginawa natin is this. Si omega O is 2 pi f0. Okay, times t. So here, yung 2 pi here gives you the unit of radian. Okay? F4 here gives you the unit of per second. Okay? And then, t here gives you the unit of second. So that pag binultiply mo to FO to t, that multiplies radian multiplied to 1 over second multiplied to second. So that gives of radian as the unit of this product. Okay? So that is why, kung naka-degrees naman itong si theta, if we specify theta here to be in degrees, okay, then we will have to convert it to radians. Okay? So to convert that to radians, so we will have theta in degrees. So theta in degrees. Multiply natin siya with pi and then divide natin with 180 degrees. So that we cancel this and then we leave pi radians as the unit. Okay? So there. So yun. So that's your current. Okay? While your voltage is this one. So volts is 10. Again, the peak value or the amplitude of the voltage is 10 volts. Cosine of omega O times t. Okay? Now, we use equation 5, to compute for the instantaneous power. So the instantaneous power is given by this one. Ito yung instantaneous power natin. So we use that, okay, to compute for the instantaneous power produced by the waveforms at a given time t. So kung ito yung current produced by your circuit at ito yung voltage produced by your circuit at any time instance, okay, then using equation 5, we simply multiply them. Current times volts. Just remember lang that we have to use the operator dot asterisk. Okay, we use the operator dot asterisk because we would like to perform array multiplication. So there. Now, we try to interpret the results. So what we do is we arbitrarily choose points in time, okay, to see how much power is produced by the voltage and current waveforms on those instants. Okay, so for example, your voltage waveform would produce negative 1.8738 volts at time instant of 0.012 second. Okay, at that same time instant, okay, the value of your current waveform, okay, would have a value of negative 0.93691 ampere. Okay, so yung product na yun, ito, tsaka ito, okay, gives you the instantaneous power of 1.7556 watts, okay, at the time instant of 0.012 second. Okay, so ayun. Now, we have done that. Okay, we have tabulated that for different values of time here. So nakikita natin na yung instantaneous power niyo is nagbabago. Okay, obviously magbabago yan kasi nga since your voltage waveform is changing its values over time. Okay, and your current waveform is also changing its values over time. Therefore, yung product nila would also change in value. So therefore, every time instance, nakakakuha tayo ng iba't ibang value for your instantaneous power. Now we can see if we actually plot, okay, if we actually plot yung voltage waveform niyo at saka yung current waveform niyo, okay, take note, mag-iba scale niya. This is from negative 10 to positive 10. This is from negative 5 to positive 5. Okay, at mag-ibang units yan actually, pero the time scale is the same. Okay, so as you can see, this is your voltage current waveform tsaka voltage waveform. Okay, again, even though these waveforms have the same shape or have similar shape, these are not similar waveforms. Okay, so not similar because yun nga, magkaiba nga yung mga scale niyan. Okay, so that's one thing that you have to be mindful of when you are reading waveforms. You need to be aware of the scale, okay, of the values as well as the scale of the time. Okay, now here the scale of the time is the same, so which means this value here and this value here occur at the same time. Okay, but they are of different quantities. So ito, this is negative 10 volts. Ito naman, this is negative 5 ampere. Okay, so this is the voltage waveform and your current waveform, and this is your instantaneous power waveform. Okay, so yung product nito at saka nito, ito. Okay, so as you can see, again, iba na naman yung scale nito. Okay, this is from 0 to 60. Okay, it's from 0 to 60. So, ayun. It seems that that the instantaneous power would never be negative. Okay, since pareho kasi ng phase si voltage at si current waveform. Pag positive si voltage, positive din si current. Pag negative si, tuloy niya. Pag positive si voltage nyo, positive din si current nyo. While pag negative si voltage nyo, negative din si current. So, if you multiply them, positive times positive is positive, negative times negative is positive. So, your power would always be positive. So, that's one thing that we are sure of. Okay, so kaya makita nyo, pinakababang value dyan is 0. Okay. So, we are sometimes interested in finding yung values ng peak nito. Because we would like to know the maximum power consumption, the possible maximum power that our circuit would either take in or give out. Okay. So, in that case, I have here some set of commands, okay, which use the function find peaks, okay, and that finds the local maxima, okay, of your peak of your waveform. So pag sinabi yung local maxima, it means that that value, okay, does not have any value that is higher to that value within its neighborhood. So, halimbawa kung ito, local maxima to, it means na yung dalawang kapitbahay na values niya, ito at saka to, parehong mas mababa sa kanya. So, that is why this is considered to be a local maxima. Okay? So that is what the find peaks command or function looks for. Okay? Kaya lang, ang find peaks excludes yung dulot-dulo. Okay? This one, the find peaks function excludes the endpoints in the search. Okay? So, obviously here kasi, itong part na to, or itong point na to, is a local maxima also. So, that is why, sinama natin siya. Okay? So, these are the times, okay? And these are the maximum values of power. Okay? That your voltage and current waveform will produce. Okay? So, saan natin siya makita? Sa 0, sa 0.0084, okay, sa 0.0166, and sa 0.025. Okay? Okay, so the complete set of codes for this example is found in the script file example T0P01, which is provided to you. Okay? So that's for example 1. Now, that's instantaneous power. Okay. So now, we now know yung average power. Okay. So we average now the power. Okay. Kasi actually, the instantaneous power is actually of almost of no use to us when we will be using it to describe your signal or your system. Okay. As a system specification or as a signal specification, walang masyadong intuition na ipoprovide si instantaneous power. But rather, mas makukuha natin yung intuition na yan kay average power. So, we now compute the average power as the time average of the instantaneous power. So that is, we use the time average operator on the instantaneous power waveform, okay, or that we use the time average operator on the product of the voltage and current waveforms so that we can obtain the average power. Okay? So, for us to understand the operation of that, let's work on example 2. Okay, so let's have a circuit, okay, the one that we have shown earlier. Okay, that is yung ito yung circuit, may dalawa siyang terminal. The voltage across here is VT. Okay, and then may papasok na IT dun sa ating circuit. Yan. That's the circuit in figure 2. Okay. So, here, that circuit has a 120 volt, 60 Hz fluorescent lamp. Okay, wired in a high power factor configuration. So, when you say high power factor, okay, configuration, it means that the load is almost resistive. Okay, so that implies that reactive power is zero. Okay, so let's assume that voltage and current are both sinusoids and are in phase, which gives us a unity power factor, as shown here. Okay, as shown here. Let's first compute the DC value of the periodic voltage waveform. Okay, so the DC value of the voltage waveform is the time average of the voltage waveform. Okay, so that simply is, again, since ang ating operand, this is the operand, is periodic. Okay, we will use the form of the time average operator. Okay, as in 3. Okay, so we will use this form. That is 1 over T0 times the integral of the operand times dt from negative T0 over 2 plus A, okay, and positive T0 over 2 plus A. And again, yung dalawang limits na to, these limits, you should not really be concerned about on how to find them, okay, or how to really to formally find them. The important thing is that if meron kayong waveform or if meron kayong graph, basta makita nyo kung nasan yung limits ng isang cycle, you identify one periodic cycle of your waveform, okay, and then you identify yung simula at saka yung katapusan ng cycle na yun. So the time that the cycle begins and the time that the cycle ends, yun yung limits dito. Okay, and of course, the difference of this is T0. Okay, so if this is, say for example, just say for example, this is A and this is B, then T0 is B minus A. Okay, so yeah. Now, in this case, this will be your voltage waveform. Okay, so here, we will not, so your voltage waveform, okay, VT, is, so your VT is V cosine omega 0t. Okay, that's our V. And our current, that's IT, it's I times cosine omega 0t. Again, we will assume that both are in phase so that we will have unity power factor. Okay, so kaya parehong cosine yung gagamitin natin. Okay, now, again, using this as the to find the DC value of the voltage waveform, okay, we simply find the time average of the voltage waveform. Okay, so here, we find here that the periodicity of this waveform is T0. Okay, so ito yung kanyang pinaka-periodic cycle kasi. Ito yung periodic cycle niya. From here, yan. So that is its periodic cycle. Okay? So, which means na ang ating periodicity is T0. Okay? Tapos, so this is this is 1 over T0 times the integral of Vt, which is V cosine omega t, omega ot dt. Okay, yan yung limits. Okay, again, kuha tayo ng lower at saka upper limit kung saan nandun yung nakadefine yung ating periodic cycle. So the periodic cycle begins at t equals 0. So that's the lower limit of our integral. The upper limit is t0. Yeah. So that's how we choose the limits. Okay? So there. So ito na nga yun, no? So 1 over t0 times the integral of b cosine omega o t dt from 0 to t0. Okay? So pag integrate natin to, we will have this as a constant, as a constant. Okay? So therefore, to integrate this, we will have to balance the integral with this factor, with the factor of 1 over omega o. Okay? And then the integral of cosine, of course, b here would be taken out of the integral. Okay? As because of linearity of the integration operation. And then the integral of cosine is simply sine omega o t, omega o t. Now, since this is a definite integral, we will have to replace t here with the, we will have to have this function, okay, to be evaluated as f of p. Okay, kung matandaan nyo, okay, if you want to recall, yung definite integral natin, f of t dt from a to b is f of a, f of b minus f of a. If the integral of f of t dt is f of p. Okay? So, para ma-evaluate natin ngayon yung definite integral natin, we simply evaluate the function and subtract the lower, the upper, evaluate the function at the upper limit and the lower limit, then subtract them. So magkakaroon tayo ngayon dito ng, this one would then become, ito. Okay, so gawin natin, actually, bago pala magsubstitute nung mga limits, okay, I replace omega o with, 2 pi fo or 2 pi times t0. So I replace omega o with 2 pi t0. Yun. So ito. Pwede natin siya. So ngayon, makakancel natin to. Okay. So making this to be v over 2 pi simply. Ngayon, pag sinubstitute ko ngayon ito dun sa t dito, that becomes sine of 2 pi t0 times t0. So magka-cancel out yung dalawang to, which leaves it at sine of 2 pi. While, pag sinubstitute ko naman si t0 dito, simply, that becomes sine of 2 pi over t0 times 0. So, yung product nito is 0. So, magiging sine of 0 na lang siya. Okay? Now, sine of 2 pi, kahit anong, if you check it with the calculator, sine of 2 pi is always 0. While sine of 0 is also always 0. So, therefore, yung difference na to is 0. And therefore, the DC value of your voltage waveform is 0. Okay? So, ayan. Now, actually, the DC value of a waveform is, can be easily evaluated kapag meron kayo ng waveform itself or meron kayong graph ng waveform itself. Okay? So, if there is this parang balance between the area above, the area covered by the waveform above the x-axis and the area covered below the x-axis. Okay? Usually, yung DC value ng ating ay nag-0. So, ano yung sinasabi nating area? So, within this periodic cycle, itong area na to, okay, tsaka itong area na to, okay, these are considered to be positive areas or areas above positive x-axis. Okay? Now, if you can visually see, okay, na yung area na yan at saka tong area na to. Okay, this area naman is the area below the negative x-axis, or we consider this the negative area. Okay. If you can visually evaluate na itong area na to, yung green areas ay equal sa violet areas, then yung DC value nyo 0. Okay. Pero kung hindi 0 yung difference nila, o sa palagay nyo hindi 0 yung difference nila, then yung net nila, yung net difference ng areas na yan would be the DC value. Okay, so later on, we'll have some examples na merong DC value. Makikita nyo yung area na sinasabi ko. Okay, so yeah. Now let's do the same. Okay, so we now find out that that the DC value for your voltage waveform is 0. So we do that also for the current to compute for the DC value of the current. So again, your current here is I times cosine omega OT. So ito yun. Again, waveform. This is periodic. So yung time average operator natin that we will use is yung form ng equation 3, this one. Okay, where the periodicity of the waveform is T0, and the periodic cycle is within 0 and T0. Okay, so once we integrate this one, okay, so ito may balance factor dito ng 1 over omega O, and then yung integral ng cosine is simply sine. Okay, now we replace omega O with 2 pi over T0. Okay, ito yung ginawa natin kanina, in which we will be able to cancel this. Okay, tapos ito, substitute natin siya dito. Okay, this will be sine of 2 pi times T0 multiplied to T0. So, which leads us to cancel this. Kaya magiging 2 pi siya. Okay, while, pag sinubstitute natin yung the lower limit, this one here. Okay, that gives us sine of 2 pi over T0 multiplied to 0. So, that gives us 0 as the product. So, therefore, magiging sine of 0 siya. And again, sine of 2 pi is 0. Sine of 0 is 0. So, therefore, this entire thing becomes 0. Okay? So, again, pwede nyo tingnan yan in terms of area, pero mas mamaya rin makikita yan. Okay. Now, let us look at the instantaneous power. Okay. So, if V and I are given as this one and this one, then the instantaneous power is their product. Okay? Is their product. So, now, let us rewrite this waveform. Kasi naka-square yung ating trigonometric ratio or trigonometric function. So we're not really familiar with that. So what we do is we rewrite it with a trigonometric function na hindi naka-square. Okay. So that identity or that trigonometric identity is that we require is this one. So we can rewrite cosine square of A to be 1/2 of 1 times cosine of 2A. So in this case, yung A natin is itong ito yung lumalabas na A natin. Okay. So therefore, we can write the instantaneous power as 1/2 times VI, okay, times 1, okay, plus cosine of 2 omega OT. Okay. So what now are our observations here? Okay. So you see now that the instantaneous power, okay, has a angular frequency, okay, that is twice that of the either voltage or current waveform. Okay, remember that your voltage waveform has V cosine omega OT, while your current waveform as I cosine omega o t. In both cases, ang inyong angular frequency is omega o. Now, your PT, your instantaneous power, would now have an angular frequency that is twice that of the angular frequency of your voltage and current waveform. Okay. So anong mangyayari na? What would that lead us to? Okay. It would lead us to a waveform for your instantaneous power to have a waveform that has twice the frequency or half the periodicity. Ibig sabihin, mas maraming cycles ang nako-cover ng instantaneous power ninyo in one second compared sa nako-cover ng voltage or current waveform ninyo. Okay? Or mas maikli yung isang cycle. Okay? So tingnan niyo to. So here we see that so ito at saka ito. Yan yung T0 eh. Okay? That's T0. Ito yung T0 natin. So from here up to here. So papansin niyo na in your voltage or current waveform, isang cycle lang ang nabubuo sa mga waveforms nila within the interval ng T0. Okay? But in the case of your power waveform, your instantaneous power waveform, dalawang cycle yung mabubuo niya. Okay? So that is from here to here, that's one cycle. Okay, and then from there to here, that's two cycles. So ito yung first cycle niya. And this is the second cycle. Yeah. So that's different from your voltage and current waveforms that can only form one cycle within the interval of T0. Okay? So sabi nga natin, dahil nga this one, okay, or dahil yung instantaneous power ninyo, okay, would be 1/2 times VI times 1 plus cosine of 2V omega o T. Okay? Actually, dalawa kasing terms yung your instantaneous power would have two terms. Okay? First one is this. Okay? First one is this. And the second one is 1/2 VI times cosine of 2 omega o T. Yeah. So, here, itong sinusoid niyo, okay, the sinusoid that you see here, okay, has now a frequency, okay, F0 here of, or now sa frequency of 2FO, or a periodicity of T0 over 2. Okay? So, yan na yung this T0 over 2, okay? Or 1/2 T0. It means that one cycle of PT or of your instantaneous power waveform is within 0 up to T0 over 2. Ito nga yun. Yan. from 0 hanggang 1/2 T0. Okay, you can have one cycle of your instantaneous power. Okay, so yeah. Now, so yun yung isang observation natin. Okay, so we also see that the peak power, okay, the peak of your instantaneous power occurs when the cosine function is 1. Okay? So therefore, when it is 1, okay, so kapag ka this one is has a value of 1, that gives you the maximum power. Okay? That gives you the maximum power of or the maximum instantaneous power. Okay? So in that case, your maximum instantaneous power is given as the product BI. Okay? It's given as the maximum the maximum instantaneous power. The max instantaneous power is the product BI. Okay. Now, let us now compute for the average power. Okay. Let us compute the average power. Okay. So, in this case, again, using the time average operator. Okay. This is now your instantaneous power. No? Okay. We can actually divide this into two. Into two parts. Okay. But take note that the entire thing is periodic. Okay. So, yung 1 plus cosine 2 omega OT, okay, is that entire thing is periodic. Okay. So therefore, i-consider natin what the formula that we will use here, or the form of the time average operator that we will use here is the one that is for periodic waveform. Okay. So again, that is given as 1 over T0 times the integral of the operand times dt from A to B. Again, itong A at B na to, these are the start and the end of your periodic cycle. Okay? So, we take note that since your signal or your instantaneous power, okay, if we take a look at here, okay, your periodic cycle starts at t equals 0, okay, and ends at t equals 1/2 T0. Okay, so we will set the lower limit of your integral from as 0 and the upper limit as T0 over 2. So ito na nga yun. Okay. So we now have here 1/2, okay, so 1/2 itong 2 times VI, okay, times the periodicity. Okay. So here, yung periodicity ng ating ating waveform is now T0 over 2. Okay. This is now T0 over 2. So here. So we can cancel this 2 here. Okay, leaving us the ratio VI over T0. Now, since the operand is a sum of two functions, 1 at saka ng cosine, we can actually divide the integral. Okay? So we can actually have this to be VI P times I over T0, okay, times the integral of dt from 0 up to T0 over 2 plus the integral of cosine 2 omega OT dt from 0 up to T0 over 2. So, pwede hatiin yung integral sa dalawa. Okay. Producing this for the first term and this for the second term. Okay. So, now, we evaluate now the each term. Okay. So, here, we will have it VI over T0, okay, times T, okay, from, pag substitute natin ito dun sa T natin, that becomes T0 over 2. Okay? Pag ito naman, sinasubstitute natin dito, that becomes minus 0. So, simply, that becomes T0 over 2. So, ito yun. Okay? While here, okay? So, para ma-integrate natin to, okay, para ma-integrate natin yan, again, meron tayong may balance factor tayo na 1 over omega O, okay, which we will replace with 2 pi over T0, okay, we will replace that with 2 pi over TO. Ngayon, itong TO natin magka-cancel dito, this becomes 4, okay, so that becomes 4 pi, and ito becomes sine of 2 times 2 pi over T0 times T. So ito, once na sinasubstitute natin yan dito, that becomes sine of 2 times 2 pi over T0 multiplied to T0 over 2. So that gives us, ito, magka-cancel tong 2. That gives us sine of 2 pi. Ayun. Okay. In the same manner, we will have sine of, substitute natin ito dito. Okay, so we'll have sine of 2 times 2 pi over T0 times 0. So itong padang ito, magiging 0 na siya. So that is simply sine of 0. So ito. Again, sine of 2 pi is 0. Sine of 0 is 0. So this entire term becomes 0 dahil sa factor na to. Okay? So this becomes 0 now. Ito makakancel natin. So may iwan dito is P equals Pi over 2. Okay? So that's the average power. So ayun. Now we observe, okay? We observe that that average power, okay, is also that formula for the average power, okay, is also equal to or can be attained or can be obtained by multiplying V over square root of 2 multiplied to I times square root of 2. Okay? Which is equal to dito nga. Okay. In a later example, papakita natin kung anong ibig sabihin ng V over square root of 2 ito at saka yung I over square root of 2 ito. Okay? So, but we will leave, for now, we will leave that that expression here for now. Okay? So, if you're having difficulty in performing integration by hand, okay, MATLAB may be able to help you MATLAB may be able to help you in performing symbolic integrations, okay, and we can use those, okay, to verify, okay. So say for example, if you want to find the DC value, okay, so since the DC value, the DC value of the voltage waveform is found using this integral, and the DC value of the current waveform is found using this integral. This is I, not BO. This is I, no? Okay. So, these are the following commands to perform symbolic integration. So, define natin yung mga parameters na, or yung mga variables, symbolic variables that are considered to be constant in this integration. So here, ang constants dito, ito, T0, V, yun lang. Okay. So here, tsaka I. So we define now T0, V, at tsaka I as your symbolic variables. Okay. So first we define your waveform B as V cosine 2 pi T over T0. Okay. And your waveform I as your I cosine 2 pi T over T0. Okay. Now, let us set your lower and upper limits from 0 to T0. So, ito yung T1 tsaka yung T2 natin. Okay. So, ito yun. T1, T2, T1, T2. Okay. Now, we compute now the voltage or the DC value of the voltage waveform using this integral. Okay, so pag sinulat natin siya sa pag sinulat natin siya sa MATLAB, this is 1 over T0. Okay, pwede rin yan, pwede rin that can be written also as instead of 1 over T2 minus T1, that can also be written as 1 over T0. Okay, so times the INP function here is the function used by MATLAB to perform symbolic integration. Okay, so we can have here INP, okay, of first you put in your function, your symbolic function. So ito V. Okay. Tapos ano yung variable na i-integrate natin dun sa V? So in that case, ano yung differential natin? So in that case, that is T. Okay. And then the next two arguments pertain to the lower and the upper limits of your definite integral. Okay. So that's how we how we write yung integral na to into symbolic forms. Okay? Or into symbolic integration. Yeah. Now, MATLAB will return the following results. So, lalabas yan, yung VDC natin is 0, yung IDC natin 0. So, tama yung nakuha natin results kanina na the DC values of V and I are both 0. Okay? So, we now try to find the average power, okay, by trying to integrate, or by trying to perform symbolic integration to your instantaneous power. Okay, so what we will do is we will multiply VI and use the function expand para ma-multiply talaga siya. Okay, so here I simply will simply have your P or your instantaneous power as IV, okay, over 2, okay, times cosine ng 4 pi t over T0 plus 1. Okay, so this is the MATLAB result. This is how we write it in paper. So again, yung product na yun, okay, this is simply just multiplying the instantaneous power, getting the instantaneous power. Wala pa tayong i-integrate pa dito. Okay, so again, we notice here that the frequency of this is still 2 over T0. Again, this takes the form 2 pi times F0 times T. Okay, so in that case, yung F0 natin is this one. Okay, so therefore the frequency is 2 over T0. Okay, and the periodicity is its reciprocal, that is T0 over 2. Okay, so there. Now, we find the peak power, okay, by if you remember, we find the peak power by setting yung cosine 2 omega o t or yung cosine 4 pi t over T0 to 1. Okay, so actually if you substitute t equals 0 into this one, okay, by the way, t ito not pi. Dahil palang error nito. Okay, if you substitute T0 into this function, okay, you would have the peak power. Okay, so again, magpipeak kasi yan kapag ka nag-cosine 0 ito. Okay, so this one peaks, okay, when t equals 0. So that is why we use the function subs for symbolic substitution, okay, by substituting 0, okay, to t sa function p natin. So here, function, lagyan natin yung function natin which is p. Okay. Then, what variable do we replace with or substitute? Okay, which is t. And then, what do we replace it with? So, in this case, we will replace that with 0. Okay. So, that's how we compute the maximum instantaneous power. So, in that case, we determine now the maximum instantaneous power as the product IV, which is yung nakuha natin dito kanina. Ito. The maximum instantaneous power. The product IV or VI. And then finally, the average power. Okay. So we again, we take note that the frequency of T is 2 over T0. Okay. So its periodicity is now T0 over 2. So if we apply now if we now use the TA or the time average operator. Okay. So we'll now have 1 over the periodicity. Okay. So 1 over T0 over 2 times the symbolic integral of your instantaneous power integrated against T. Okay. From 0 up to T0 over 2. That's the upper limit of your, or the upper end of your periodic cycle. So now, MATLAB would return the following average value. So that's IV over 2. Yeah. So again, the maximum instantaneous power, okay, this is the maximum instantaneous power. While this is the average power. These are also the expressions that we were able to obtain, okay, earlier for this quantities. Okay, so verify lang natin siya using symbolic integration sa MATLAB. Okay. So you can find the MATLAB commands for this example in the script file example T0302.m. Okay. So we will cut the discussion at this point, okay, and continue with the discussion on the RMS value and normalized power.